sociological model on bilingualism, which we used fractional order differential equations. There are some studies about bilingualism, like in these references, especially in Fox and Friedman models. But most of them use integer order differential systems. We will use fractional order differential equations instead of integer order ones. It has turned out that using fractional differential equations can be very useful to real-life phenomena, especially with memory effect. Thus, we use fractional order differential equations. In our model, there are three groups in a population. Two of them are unilingual, and one is bilingual population. There are some kind of fractional differential definitions, like Riemann-Liouville, Greenwald-Letnikov, and sequential fractional differential equations. But we use Caputo type fractional differential equations because in the Caputo type fractional differential equations, initial values be the same in the classical derivative. And in other type derivatives, it's very different. For example, the derivative of a constant is not zero in Riemann-Liouville or the other fractional derivatives, but in Caputo type, it is zero. A derivative of the constant is zero. This is the definition of Caputo derivative. Let me briefly talk about memory effect, why we choose fractional differential equations in memory effect. We consider this type of differential system. Here is Q is the order of the equation, and x of 0 is initial value, and Q will be between 0 and 1 in all the study. The solution of the initial value problem is equivalent Volterra integral equation. We should note that when we take Q equals 1, this equation will be classical Volterra integral equation. We take two different points of t, say t1 and t2, and write this equation for t1 and t2, and subtracting these two equations, we get such a statement. In the classical case, when we take Q equals 1, the first integral in this statement vanishes because of this statement in the parentheses. It means that we don't need any extra information before T1 when we want to find the solution of x of t. But in the fractional case, when Q is different 1 between 0 and 1, the first integral doesn't vanish. It means that we need information before the point t2. Thus, fractional order systems are more appropriate tools to model systems with memory. This theorem is very useful for the solution of the fractional order systems. We make some assumptions on the model. First, birth and death process are continuous. Second, children of unilingual parents enter the population as unilinguals, but children of bilingual parents may enter the population as bilinguals or unilinguals. Immigration from the environment and immigration to the environment are not considered. Conversion from bilingual to unilingual exists, and last assumption, conversion from dominant unilingual to bilingual does not exist. The model can be used in very different areas in the world, like Canada, the United States, or in Brussels. But mainly our study is based on the situation in Turkey. In Turkey, Turkish is dominant language with some other bilingual second languages. We consider only Kurdish as second language. As our model is of this form with these assumptions here, BI is the specific birth rate, and BI plus LI XI is that rate of XI with this assumption BI greater than BI. P2, this statement and the other is probability that a child born to bilingual parents will enter the population as a member of population X1, X2, and X3 respectively. We find the equilibrium points and their stabilities. The corollary gives positive existence of positive equilibrium, and a numerical method and a simulation route. And that's the numerical results of the expected situation in Turkey. The dashed curves are integer order differential equations, and the other ones are fractional order differential equations. We see that in the fractional case, curves approach fast. Yeah. That's all.
Thank you, speaker. Any questions?
So you said that you're in the assumptions you weren't considering immigration to the population and immigration from the population. Was there a particular reason why you chose not to include that?
Immigration is very difficult for this kind of models